So today we will go through projectile motion, a common mechanics topic. Let's first take a look at how to represent velocity in its horizontal and vertical components. If we have a velocity at an angle to the horizontal, you can use basic trick to find the vertical component. So the vertical component will be opposite, right? Therefore, that will be v sine theta. And in the horizontal direction, we will get v cos theta because the horizontal is adjacent to our hypotenuse. We can represent this in vector form as v cos theta I plus v sin theta j. In most projectile motion questions, we neglect air resistance. So air resistance acts on an object, let's say this white ball here, it acts on the object horizontally. So since we neglect air resistance, that will mean that there is no acceleration or deceleration horizontally acting on this object. Therefore, we can use the velocity equals displacement over time equation for horizontal component of velocity. Now let's apply this for this question. So the ball is projected horizontally at a speed of 4 meters per second. So we can apply 4 equals it lands at a distance of 10 meters away, 10 over time. Therefore the time the ball will take to land is going to be 10 over 4, which is going to be 5 over 2 seconds. Consider this ball that is falling vertically downwards. So since in projectile motion that we neglect air resistance, we can say that this ball moves freely under gravity. That means we assume that the only force that acts on this ball is its weight force. So this ball will have a deceleration or acceleration vertically only due to its weight force as in Newton's second law. Some key terms in projectile motion are the range and the greatest height. So the range is the distance considered along the horizontal plane that the object travels, and the greatest height is the maximum height that the object reaches considering the vertical plane. And in this greatest height, the object hits a vertical velocity of v equals 0. The horizontal velocity will not change, but the vertical velocity will become 0. Let's take a look at this problem. So let me first find the time of flight as asked in the question. So I'm going to consider the vertical component of velocity. So when you consider the vertical component, you must take it with respect to upwards or downwards. So I'll take it to be upwards. Now, as we know, the vertical speed here in magnitude will be the same here, but the direction will be changed. So even though it's 3 upwards here, it will become 3 downwards here. So a Stewart equation we could apply is v equals u plus at. Now the final speed will be, with respect to the upward direction, it will be minus 3, and the initial speed will be 3 plus acceleration value is going to be 9.8 in magnitude, but considering upwards we must take it as minus 9.8 because weight acts downwards. So therefore we can now solve for t. 9.8 t equals 6, t equals 0.612 to 3 significant figures. Moving on to the B part, we are asked to find the range of the ball as it moves along this plane, and the range is considered along the horizontal plane. Let me take the right to be the horizontal direction. So as we know, range is equal to the initial velocity times the time, and this can be derived using v equals d over t. So the range will be the horizontal component of velocity, that is going to be 5 times time as been seen earlier is going to be 0.612, and our final answer will be 3.06 meters. So here's another problem that I did. So in this question we are asked to find the time of flight. I considered the vertical component of velocity and displacement, and I took the positive direction to be upwards. So I use s equals ut plus half at squared, and I substituted the displacement, velocity and acceleration values. I got a quadratic, and I ended up with t equals 5 or t equals minus 85 over 49. So since time cannot be negative, we are left with t equals 5, which is our final answer for the time of flight. In some questions, you might get two positive time values for the same displacement. So that would look something like this, which are at the same displacement with respect to the ground. So these type of scenarios occur when you are asked to find a particular time range for which the speed of the ball is greater than a particular value given in the question. Thank you for watching this video. I'll see you in the next one.